right, guys, so you decided to go ahead and do our hands-on project. So great news. So your project looks like this, okay? So rules for this, we need to cut these shapes out. So what you're gonna do is you're gonna just cut along the bold line, not the dotted lines, okay? So what I want you to do, at least do one of these right now, and then we'll go through the directions after that. So just hit pause, cut one out, and then I'll tell you what to do after that, all right? All right, so I've cut out a couple of mine. Hopefully you've cut out a couple of yours. So like I have this one right here, E, okay? So E's right in the middle of it. What you're gonna do now that we've cut around the outside of it is has little fold lines in it. That's what all of our dots are, little fold lines. So you're gonna fold it along those. When you fold it though, you wanna fold it so that all of the little squares end up on the outside of it. So what I mean by that, I'm going to fold this one up quickly so you can see it. When I fold this, there we go. And I've built basically a little box, just doesn't have a top on it, okay? But now when I look at it, all the squares are on the outside. Now what we're working on is, you've been doing stuff with area and perimeter. And area and perimeter are great. Perimeter is great for being able to measure straight lines around something and getting an answer for a measurement around an object. Area works good for any flat objects and finding out how many squares can fit inside of it, which is often used. But more often than not, in the real world, what we tend to end up having is not flat objects. We have three-dimensional objects. That's what we've just built, a three-dimensional object. Now, a three-dimensional object doesn't always help to measure around the outside of it, and it doesn't always help to measure just how much fits along the bottom of it. What we tend to measure with a three-dimensional object is how much room we can fit in the whole thing, three-dimensionally. So we still have a length and a width to it, but now with the third dimension, we also can stack things up, and we have a height to it. So that's what we're looking at now, is we're going to look at all these little shapes, and we're going to try and figure out how many units can fit in there. Now, the first thing we do before we get started on this is we've got to figure out what unit we're using. For perimeter and length measurements, we just use one straight unit, centimeters, inches, yards, miles, something like that. When we switched over and we were doing square units to fill up a flat shape, we were using square inches, square centimeters, square yards, square miles, whatever you wanted to. Now, we're not using flat squares, we're using a three-dimensional object. So if we move up from a square to a three-dimensional object, we would end up with cubes, okay? That's right, cubes. You've used them for base 10 blocks and all kinds of things. Now we can actually use them as a unit of measurement, okay? Now, it doesn't matter if you were doing cubic inches, centimeters, anything like that. Same as when we did all the rest. Future reference, the regular cube is a cubic centimeter. But we're trying to figure out how many cubes are in there. Now, I could take this and I could tape it up and I could take cubes and I could actually stack them in there and I could see how many cubes I could fit in here, okay? I could take the time and do that. That is something I'm capable of doing, okay? And in years past, if we were at school right now, that is what I would actually have you do, okay? I'd have you fill this up. We'd build these little shapes. We'd see how many were in there, and we'd have a great time doing it. Everybody would learn so much, and the life would be great and great, okay? That's not the possibility this year. So I can do it, and I could show you, yep, look, I fit 8 in there. That's how many fit, okay? But we're gonna have to figure out other ways of doing this. So that's why we have the grids along the outside. So we should be able to take a look at it and just imagine how many are fitting in based off of the cubes that we see on the outside of it. So when we take a look at it, I'm going to need my formula for volume. We have a formula for area. That was length times width. We need a formula to be able to solve volume, okay? Now, it's almost remarkably the exact same thing, because if you think about it, you're still going to have, on any given shape, you're going to have a length across it and a width going backwards. So length and width are still there. So then what's different? What did we add? Yeah, height. So we've added a height to it. So when I look at this, and I hope that when you actually build this and you have it in your hand, this little E that I have in my hand, I can clearly see, looking down into it, that there's room that I could fit 4 cubes in there, okay? And then there's 2 layers of it. There's a bottom layer, and then there's a top layer. So I know I could have 4 and then another 4. That would be 8. Now, that's one way we could do it. The other way is our formula. Let's think about it. My length is 2, my width is 2, and my height is 2. So I would have 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. Okay, so our formula for volume, length times width times height, should work. Now I'm going to do one more real quick, so I'm going to fold it, and I'm going to show you this one, okay? Okay, so done folding. So I've got mine ready. This is A, so it's probably the first one a lot of you cut out because a lot of us always start with the first letter, A. Now this one only clearly has 1 layer. Okay, so I know it has a height of 1. I can only fit 1 row of cubes in there. So that part's done. Then I could look at, well, what's its width? 3. All right, and then I can also take a look, what's its length? It's 6. So if I was sitting here and I was going to fill it in, I know that I could fit 1 layer of them, a height of 1, and then I'd have an array of 3 by 6. 3 by 6 is 18. So I know there's 18 that I could fit on the bottom, and since there's only 1 layer, 18 times 1 is 18, and that's it. Now, if this was a little bit taller, if it had a height of 2, then I'd have 2 groups of 18, 18 and 18, which is 36. If there was 3 rows, then I'd have to multiply by 3. Okay, so today I want you to go ahead, cut out some of the shapes, take a look at it, see if you can figure out what the volume of these would be. I'm going to put the answers in there so you can take a look after you solve it, after you fold them up, if you can figure out what the dimensions and what the volume would be. And then even if you did choose this, which I'm assuming if you watch this, that's what you chose, I still want you to practice 2 of them on the computer. So if you follow along with the slides, there's 2 to do on the computer, just so you can practice doing it in a picture form as well. And I also have another quick video of how to do it in picture form so that you can see it, so you understand what's going on with it. All right, well, good luck. I hope you have fun being able to manipulate and move things around. Try your best. That's all anyone can ask. If you need help, stop by at office hours.